Hey guys, how's it going? Hey, Dan, it's nice to see you all here. Ian was like, first like, no. Oh, first like. I see what you did there. Callista was first in. Callista's on the ball when it means getting into the the YouTube. I'm Jack. I'm dead. You weren't even close today, Jack. Callista's on the ball when it means getting into the. Wait, what? I'm not YouTube. First like. I'm Jack. Right. Okay. So, guys. I need to put my little fan on now because I've suddenly realised that my laptop's overheating. I suddenly realised we have 2 more lessons of chemical tests. So this is perfect. So today we're going to do the chemical test for the complex ions. Then tomorrow we're doing the chemical test for gases. Thursday, revision lesson where I'm going to go through exam style questions, and your test is Monday. So your test is on Monday your test is Monday the 8th. No, Tuesday the 19th. Excellent. I like it. Cool. Right, let's crack on, guys. Share screen. Boom, boom, boom. Dun, dun, dun. There we go. And then I'm going to pop out the chat for my... I'm just checking my fan. There we go. Okay. Popped out chat. Get rid of my YouTube video. I'm desperately trying to sort out my laptop so that it doesn't make any silly noises or whatnot. There we go. I'll then switch the camera. Switch my camera to the clip cam. Boom. There. Check my audio is running through my laptop. Yep, we're all good. And we're up and running. Right. Year 10, chemical tests. Cool. We're up and running. Boop, boop. Yeah. There we go. Right, so this is chemical tests. Is that really loud? Oh, no, it's not. Okay. So this is iGCSE. Oh, let's switch to black. iGCSE chemical tests. Chemical tests, lesson 4. And this is complex ions. Okay, so learning objectives. Number 1, no complex ion tests. Number 2, know your observations. Number 3, be able to write equations for each test. Write equations for each. I like it. Seems very reasonable. So first activity, everyone, let's aim for 10 likes. Thanks, Jack. You're such a star. Do you know I've now got 403 subscribers? Woo! Yeah! Okay, I went supersonic there. Didn't need to do that. But it is awesome. 403. It's really funny. Okay, so complex ion tests. So first activity that I'd like you guys to do, 405. So first activity, complex ions. So we know these guys. I've already taught them to you. I taught them to you when we were doing formula. Do a special episode to celebrate what, like set fire to stuff. If I think I go back to school on Thursday. You guys don't, but I do. And I might do some cool stuff. We hit 11 likes. It's amazing. Thanks, Jack. You're so funny. So, guys, what I'd like you to do, please. So, nitrate ion formulae. Go. Off you go, guys. Write the formulae here, please. Next, hydroxide ion. Hydroxide ion formula, please. Carbonate ion. Carbonate ion here, please. Sulfate ion with an F. It's actually, the P actually is an ancient English misspelling. Can you believe it? Please don't set fire to me. And the last one is ammonium. That one, of course, needs to be flagged as special. Ammonium ion. This one is of particular importance. You guys will probably already know. For those people in the room who, of course, have been learning my others, silver. I'll just give you the answer. Silver, but not complex. Silver ion. Yeah, not complex. Lead ion, not complex. Zinc ion, not complex. Mercury, not complex. Yeah, they're just other ones that you definitely need to know for GCSE. Definitely. Really handy, especially silver. Holy moly, do you need silver? Zinc actually is annoyingly, I didn't really add that to your thing. Anyway, the great thing is they're all really similar. There's great similarities here. Okay, so guys, I'd like you to pause the video, fill in the answers, and then it's going to be marked at a 9. Okay, so nitrate, NO3 minus. Do you like the voice? I like that one. NO3 minus. Hydroxide, OH minus. Carbonate, CO3, 2 minus. I don't need the circling. I was circling it just for habit. Sulfate, SO4, 2 minus. Ammonium, NH4 plus. There we go. So that one's out of 5. And then silver, Ag plus. Lead, Pb2 plus. Zinc, Zn 2 plus. Mercury, Hg2 plus. On the chat, please, can I now have, out of 5 and 9, what did you get? So you might do 4,8. Yeah, I think that'd be reasonable. It's because really the one that I'm actually bothered. Did you know that bothered was added to the dictionary? Bothered? Oh, I love it that Jack's asking about the A-level phosphate. Happy for you to add it, Jack. Happy for you to do so. Phosphate is A-level, but it's lovely that you want to add it. You can, yeah, so that can be whether or not. So again, have a go at writing it. The answer, pause, PO4 3 minus. And that's out of 1. So you can give me 4, 8, and 0, if those are the numbers you got. The one that I really care about, though, guys, is this one. These ones are the ones that I'm really testing you on today. I need you, and of course, phosphate is part of that, but it's the A-level one. And I love Jack. Can I just say, it makes me so, so proud. And Julius didn't get the phosphate, but that's okay, Julius. It's not one that you need yet. You know, I love that you guys like genuinely love chemistry, and you know, you actually like the fact that I give you these little extra bits because, oh my God, does it make a difference going to A-level? Like all of a sudden, instead of having all this extra stuff to learn, it's like, oh, I've already got that. And this is the right time to do it. Well done, Lauren. Great job. Ian, good man. Well done. Love it. It's a great set of results. I'm loving this. Zyna, full marks. Smashed it. Absolutely smashed that. Well done. Owen, well done. Good man. It's the 5 that matters. It's what I want. Well done, Ian, for getting the phosphate as well. Good man. Cool. You can continue to post those, guys. Well done, Callista. Well done, Tanisha. It's a great set of results. I'm happy with that. Yeah, happy. Okay, let's move on. So, guys, we now need to test for each of these. Now, I'm just going to let you know, here's a lovely thing about GCSE. They've been steadily removing them. So out of the 5, you only actually now need to test for 3, which is amazing. I'm going to teach you all 5 because I think it's nice to do so. But in reality, there are only 3 that you need. So testing for complex ions. Okay. So the first one, nitrate. Testing for the nitrate ion. Brackets NO3 minus. This is no longer needed at GCSE. It's not needed. I'm teaching you this for fun, So the test and observations. Observations, Margot, Yorkshire. Oh no, I've gone Yorkshire. Try Welsh accent. Observations. Not very good at Welsh though. Test and observations. There we go. So the test for this is not needed. I'm also going to say iGCSE. iGCSE. No. Nope, not needed. But I'm teaching you anyway. The test is called Devada's. Oh, I think it actually has an R in it. Devada's alloy. Devada's alloy. It will generate. Now, this is the nightmare, of course. The reason why this was taken away is because it's actually a two-step test. But the ammonium ion is a two-step test, and they kept that one. It's annoying. Devada's alloy. Observation is you'll produce ammonia, which you test for with damp red litmus paper, and it turns blue. I'll talk to you about the ammonia one in a minute. Observation, effervescence, fizzing, effervescence. You don't need to say that word though. Yeah, I don't like that because I never know how to spell it. You can just say fizzing. You will see fizzing, and the gas is ammonia. And you'll actually test for that. I'll add that on later. But you do not need to know the nitrate ion for GCSE, which is awesome. They just removed it. They removed it about 10 years ago, if you're interested. 10 years ago, you had to know it, and now you don't. Next, hydroxide ion. OH minus. Oh, I'll put hydroxide ion. And hydroxide ions, OH minus. The test is needed for GCSE, yes. And the test is to add universal indicator. Universal indicator. Observation turns purple, turns green to purple, dark purple to boot. There we go. Turns green to purple. Nice and easy. And by the way, this is because it's an alkali. OH minus. It's just that simple. It's just an alkali test. That ion there is what makes an alkali an alkali. That's actually a nota bene. I'm going to add that nota bene next door. Do it in red. Nota bene. Yeah, important notice in Latin. OH minus ion. Brackets hydroxide ion is what makes an alkali an alkali. It's what makes an alkali an alkali. That's so stupid. Does that actually make sense? Am I going mad there? OH minus hydroxide is what makes an alkali an alkali. Yeah, no, it is correct. It's stupid English. It's really weird, that. Cool. So we've picked up another test. Next. This is where they now keep going. So we've now got carbonate. Carbonate ion. Carbonate ion. Brackets CO3, 2 minus. This one is needed at GCSE. Yes. Oh, suddenly realized you need 4 for GCSE. Yes, makes sense. Yeah, it does, right? Just weird to say an alkali just right after it, but it does make sense, right? It's weird. So the test for a carbonate is add dilute sulfuric acid. Dilute sulfuric acid. And you will see fizzing. Now, there is a continued test on this. Fizzing, brackets, if you're really fancy. Effervescence. I can't actually spell effervescence. Is that how you spell it? Someone help me out. Is that how you spell effervescence? I try to avoid it as best. Effervescence. Effervescence? Yeah! Winner. Whoop, whoop. Means bubbling, means fizzing. You'll see fizzing. Observation. Fizzing. And then what we'll do is there is an extension to this. You then have to test for carbon dioxide. Test for CO2. Bubble the gas through lime mortar. Test for CO2. There's a follow-up test that always comes similar. Same with the nitrate ion. Yeah, add acid and it will fizz. Next. You're doing well. Next one, sulfate ion. SO4. No. Sulfate ion. SO4, 2 minus brackets. This one is needed at GCSE. Yes. Okay, this one is slightly more complicated. So this is add, number 1, add dilute HCl, hydrochloric acid. Add dilute hydrochloric acid followed by barium chloride solution. Followed by barium chloride solution. I know, guys. I know this is a tricky one. I get it. Observation. White precipitate. White precipitate. There we go. White precipitate. Right. Last one. Ammonium. Oh, made a mess of that. Ammonium ion. Brackets NH4 plus. Right. Yes, GCSE, it's needed. And so what we do in step number 1 is you add, step 1, add sodium hydroxide solution, dilute NaOH solution, brackets aqueous. I'll put sodium hydroxide solution. Step number 2 is warm. Step number 3, damp red litmus. You're actually testing for ammonia gas. Damp red litmus turns blue. Observation. Damp red litmus paper turns blue. Technically, that is the observation. Litmus, red litmus turns blue. It is actually the observation. Red litmus turns blue. Le bleu. And that's it. Right. I am going to give you the equation for each one of these now. The equations do every now and again crop up at GCSE. They're relatively rare, but I do see the value in what's happening here in showing the equations for each of these. Now, I'm actually not going to bother showing them for the top 2 because the indicator and the Devada's alloy are relatively complicated, and you don't have nitrate ion anymore. It's no longer needed at GCSE, so that's nice. Can I just point out, by the way, how to spell what? Litmus. Oh, litmus. It's a U. Litmus. Oh, by the way, yeah, damp. By the way, please notice the damp bit. You need the damp. That's really important. So this, although this has been removed and was removed about 10 years ago, they do every now and again. I've seen it where they've not asked you for the test, but described it, removed 10 years ago. And they were doing a clever trick. They were using it to freak people out. the questions, so the reason why they did it is because it links to another test that is in the list. This one links to the ammonium ion test because they have the same endpoint. You actually do Devada's alloy followed by, so just to let you know, the actual test should have been Devada's alloy and then step 1, add Devada's alloy, step 2, damp red litmus, sorry, that's actually better, turns blue, which is the test for ammonia. So that's actually what's happening. And they tied it together. And what they did was they said, question was something akin to, Jack was testing for the nitrate ion using Devada's alloy, and he knows that the test produces ammonia gas. State how Jack tests for ammonia gas. It had nothing to do with the nitrate ion. Nothing. It was ridiculous. Absolutely nothing to do with the nitrate ion. They told you what it was doing. It was just the test for ammonia gas. But everyone came along going, Mr. Duncan, I didn't know how to test for the nitrate ion. And I'm like, I told you in the question, what are you talking about? So the question was there just to freak people out. But it's nice to talk about that every now and again. Okay, but the other ones you do need equations for, these three. So these three now require equations. Just these three. These three are the top, these three here are the top 3 complex ion tests done at GCSE. You guys need to realize that these are on every single paper. Yeah, and here are the equations. So carbonate ions and acid. So the carbonate ion, CO3 2-, reacts with H+. And this is what makes an acid an acid. Nota bene. Nota bene. H+ is what makes an acid. So stupid. An acid. Oh, so funny. H+ is what makes an acid an acid. So I add acid, I'm adding H+ to this. So we can put underneath here acid. Yeah. And by the way, just to let you know, the carbonate's acting as a base. It's the opposite's reacting with it. If anything reacts with an acid, it's a base. And what we form is H2O and CO2 gas. And the gas is what we see fizzing. Balance it, and now it balances. Whoop, whoop. Look at that, isn't that cool? So the H pluses just rip the O off to form water, and CO2 is left behind. So all that's happening. They literally rip off the oxygen. Quite literally. Quite literally. And then we can test for CO2. At this point, I think that's a reasonable thing to do because they roll these two together. Test for carbon dioxide is bubble through. That, by the way, that there is why everybody loses this mark because you have to say bubble through. Because you can't just have lime water there. If you just pass CO2 over lime water, it's not going to do anything. Bubble through. So important. Oh my Lord, all my students lose their marks because of that. Bubble through lime water. 1 mark. You can't just say lime water. Yeah. And it will form a white precipitate. Or, as you're allowed to say at GCSE, if it goes cloudy or milky. Oh, just white precipitate, formed. And I'll give you the equation. The equation is this. Calcium hydroxide, aqueous, is lime water. That there is lime water. Lime water. And it reacts with the carbon dioxide gas to form insoluble calcium carbonate and water. And that is our milky, cloudy, white PPT. I prefer white precipitate. It's better chemistry. I hate milky and cloudy. Drives me nuts. There we go. So carbonate ion, we realize these two tests are going to go hand in hand. Yeah, but great chemistry. Next, right, sulfate ion. So Now, first things first, this one requires some explanation. This one's really important. I'm going to double star it every year without fail. Yeah, this one's important. So here's the thing. Why the acid? We did the acid for the halide ion test as well. It's very strange, but the reason is actually the same. So in the sulfate ion test, stage 1, you add acid. This is where I need to figure out how in my notes I'm going to organize this. So sulfate. Step number 1 is add acid. Well, what's the acid doing? The acid is actually destroying any carbonate ion impurities, turns it into CO2 and water. So what it's doing is removing or destroying, whichever one you prefer, removing carbonate ions. Carbonate ions. The reason why is because in the second stage, we add barium chloride solution. Now, barium chloride solution contains Ba2+, and the Ba2+ loves the sulfate ion. And these two will bind together to form barium sulfate, which is a white solid, white precipitate. Now that makes sense, but where's the carbonate ions coming in here? The reason being is because barium 2+ ions will also bind to the carbonate ion to form barium carbonate, another solid white precipitate, white PPT. And this will give us a false positive for SO42-. So we need to remove these before we do the barium chloride test. This was exactly the same in the halide ions. When we did the halide ion test, the halide ion, we were testing for Cl-, Br-, and I-. And what we were doing is we were adding silver nitrate. Now the silver nitrate contains Ag+, and that Ag+ loves the halide ions, and it'll form AgCl solid, a white PPT. And then it'll also form AgBr, a cream PPT. And it'll also form solid AgI, which is a yellow PPT. But before we added the silver nitrate, we had to add dilute nitric acid. So before we did this, we add before the AgNO3 silver nitrate, we add nitric acid, which is HNO3. Notice I'm not adding in another complex ion from a different acid. You can't use HCl because HCl then adds chloride ions, which will give you a false positive for the chloride ion. So we add nitric acid, and what happens is the H+ reacts with the carbonate ion to form CO2 and water, and it destroys the carbonate ions. Why does this need to be done? Because silver reacts with the carbonate ion to form white silver carbonate solid. Balance it, which will give us a false, which is a white precipitate. And that will be a false positive for chloride ions. So we need to destroy it. We destroy the carbonate so that reaction can't happen. So there are only two tests where you have to add the acid first. The sulfate ion test, and you've got barium chloride and hydrochloric acid. Notice the similarity, by the way, just to do a summary of those two, which is tricky. So if we're testing for the sulfate ion, look what we add. Number 1, add HCl. Number 2, add barium chloride. Notice the same anion. We don't want to add another anion. The acid matches the test. In the halide ion test, what do we add? We add number 1, nitric acid, and number 2, silver nitrate. Notice the similarities. We're adding the acid which matches the test, and these are doing the same job. Yeah, these are removing carbonate ions. Removing, and for the same reason, carbonate ions. Yeah, because they're going to get precipitates if we leave them. And by the way, for those people who are interested, the carbonate ions are everywhere because of CO2 in the atmosphere dissolves into water. The CO2 in the air you're breathing, yeah, in the air you're breathing, there is carbon dioxide. We know this because it's causing global warming, yeah, and we're breathing it out and we're burning stuff, yeah. And what happens is in the water, in any water, bodies of water, the CO2 will dissolve. It'll actually go into the oceans. And the CO2 reacts with the water to turn into carbonic acid. And the carbonic acid contains H pluses, 2 of them, and CO3, 2 minus, which is, these are what make it an acid. This is called carbonic acid, by the way. It's why the oceans are acidifying. It's why this is why the coral reefs are getting bleached. The pH of the oceans is dropping. And the algae, so coral reefs are a fine, delicate, they live in a, talk about mind blank. When two things live together in harmony, it's called a synergistic relationship. And coral reefs are actually a mixture of like an algae and something else, and another structure, and they live together. And what happens is when the pH drops, the algae is expelled. There is actually a video. So coral bleaching. Like what happens is they lose all their color because what they do is they release it's really sad. There's a video of this I watched recently. There was a video which actually showed it happening in fast time. It was really sad. David Attenborough did it. It was amazing. Worthwhile watching his David Attenborough's recent one. What was it called? A Life on Earth? Something like that. An amazing show. And it has great chemistry in it too, especially with the oceans. Now, guys, that brings us to the end of the... No, it doesn't. One more. The ammonium ion test. Right. So here's what's happening with ammonium. I'll make my pen a bit thicker. Wow, I've got way too big. The ammonium ion reacts with sodium hydroxide. Now, the sodium hydroxide produces the OH minus ion, which is an alkali. Yeah? I'll put brackets. NaOH was the test. The sodium hydroxide is part of the test. You've got to say that. You can't just say OH minus. And what's going to happen is the OH minus is going to rip off a H and turn into water. And it becomes ammonia gas. Now, that ammonia gas is going to dissolve into the water. So what we now need to do is we now need to heat. This actually becomes ammonia aqueous, if you actually want to know the real bit, because it's dissolved in the water. So I can draw this out for you. So if we've got ammonium ions here, when you add the sodium hydroxide rips off a H. I can even draw it out to you via sticks. Yeah, here's what the ammonium ion looks like. The nitrogen's fully positive. And the OH minus ion now rips off a H. It tears a H off. It just rips it off to become water. So the OH minus ion goes to the OH and rips it off, turning into H2O, and this is left as ammonia. Now, the ammonia, of course, is then still in the water. It's aqueous. So now what we know is we need to get it out of the water. So how do you get it out of the water? You warm it. So now when you heat it up, it'll drive the gas out. We learned this when we did solubilities of gases. When you heat up a when you heat up a solution which contains a gas, you'll drive out the water because solubility decreases with temperature for gases, opposite for salts. We talked about this with my fish, you might remember. So back like a long time ago, I remember when I was a kid and I went to a school fair and I won a fish at the school fair. And when I took it home, I was going to put it into the fish bowl. Now, my dad told me that, oh, no, you can't just add it to the water from the tap because the tap water contains chlorine and the chlorine will kill the fish. So what you need to do is you need to get rid of the chlorine. So how you get rid of the chlorine is to boil it. Now, when you boil the water, you drive out the chlorine and then you leave it to cool down and you put the fish in it. Well, actually, it turns out it's a bit more complicated than that because there are two reasons. Number one is I didn't wait for the water to cool down and I cooked my fish. Bit of a disaster. Yeah, that wasn't very good. My dad thought it was hilarious. I was very upset at the time. There was actually another problem. So my dad went out and bought me a second fish. And I boiled the water, got rid of the chlorine, waited for it to cool down, and I put the fish in it once it cooled down. And the fish proceeded to die almost immediately again. And the reason being is not only do you drive out the chlorine, but you also drive out the oxygen. And then there is no oxygen in the water. So when you add the fish to the water, there's no oxygen and the fish suffocates. So my fish died yet again. My dad, once again, thought this was relatively amusing, although he'd just gone and spent money on a fish and had to go out to the fish shop to go and get me a fish, and he was a bit annoyed about this now. Can I just point out, totally not my fault. I didn't know it was going to die. So what you now do is you take the third fish, dad goes to the shop, buys me another fish, comes back, I boil the kettle, wait for it to cool down, and then you have to wait for 4 to 5 hours before you put the fish in it to let the oxygen redissolve back into the water from the air. Then your fish will survive just fine. So just to now tell you that what we now do is warm it, and the ammonia aqueous will become ammonia gas. And that is done through warming. And then you test for ammonia gas with damp red litmus. Damp red litmus. You take damp red litmus and you have to make it damp, that's correct. If it's not damp, because what's happening is it's dissolving into the water. Yeah, you make this damp so it becomes like a darker color, and then you show it the gas, and what will happen is it will turn blue. So, and there's no equation that you need for that one. Don't need that one, but it's nice to do so. Nice to understand what's going on. It's just changing. It's becoming the hydroxide again back into the. It's becoming. Oh, I could actually show you that. I don't need to, but the ammonia reacts with water to form ammonium ions. And how does it do that? The ammonia is stealing a H, and you form a hydroxide ion, which is what makes an alkali, and then turns the red to blue because it's alkali. Isn't that clever? Anyway, you don't need that one. I mean, you can do it. It's nice to do so, but it's cool. Anyway, that brings me to the end of my lesson, and I'm done. So my learning objectives. Number 1, know the complex ion tests. Number 2, know your observations and be able to write equations for each. So what I'm going to do is, guys, I'm going to set you a homework because we have now covered, apart from the gas tests, but we have covered all of our ion testing. We've got gases to do next: hydrogen, oxygen, carbon dioxide, ammonia, HCl, all of these gases, SO2. We've got these gases to test for, but those gases are separate. They are gas tests, but we've now finished our ion testing. So I will now send you out the homework of ion testing to bring all this together and to help solidify this. I know, by the way, look at that. That is hardcore chemistry. Like, seriously, guys, this is real chemistry. I know it's tough. When you see the questions, you'll realize how easy this is. You've just got to know them. And when you see the exam questions, and all the homeworks I'm setting you are based on exam, just go through the papers, guys, and pull out all the testing questions. You'll see how easy this stuff is. The equations are rare. I know the equations are hard. I get that. But don't worry. They're actually, they're very, very rare. Most of the time it's, what has he added? What does he see? And you're done. That's it. So don't worry. I don't want you to worry about the equations because they are tough. Every now and again, most common equation is that one. and every now and again one of these, every now and again one of those. But other than that, it's kind of it. So don't worry, we've done them all, and we will see. Guys, at this point, I will leave you be. There we go. Go back to here. Way, we're done. So ion testing done. One more lesson on gas tests. And guys, I am so aware that this is dull. In lesson, this is one of my favorite topics because it's just practical every lesson, and we're missing it. And I'm so sorry. When we get back to school, it's the first set I'm going to do. I'm going to get you to do every single test, so we can just have 2 weeks of non-stop practicals as soon as we get back. I hope this has been okay. I'm sorry it was a tough lesson. If you need any help, I'll set you up the homework. If you need any help, give me a shout and I'll always help. See you later, guys. Have a good day.